The Palo Alto Network's Firewall, Device and Architecture Overview. This is where we're going to kind of get started and see exactly what Palo Alto Networks is all about. We're going to take a little bit of time to kind of get familiar with what Palo Alto brings us, and basically their device portfolio, and a little bit about their internal architecture as well, to kind of understand about what sets them apart. I mean, these days, a firewall is a firewall is a firewall, right? You block some stuff, you do some other things, and magically you can call yourself a firewall. Cool thing is, everybody, and I mean, thank marketing, of course, but everybody's calling themselves a next generation firewall. Well, interestingly enough, Palo Alto is one of the first ones to do this, and certainly the ones who kind of set everybody else on edge, if you will. When you start looking at like the Gartner, the Magic Quadrants and stuff that are coming out, those are where we start to look at Palo Alto Networks setting themselves apart from everybody else in terms of the quadrant that they happen to be in. The visionary, the leadership, the technical prowess, everything that kind of goes with that, where everybody else wants to be. And there's been a whole lot of what's a good technical term? Brouhaha. Fighting back and forth among the vendors on different things. But, irregardless of that, you look at what it is that's interesting, you look at what it is that's different. And part of that comes from not just the portfolio itself, because, again, they're devices, but the architecture and how things are processed and how efficient the device happens to be for securing your network. So that's kind of the catchy part to all of this in there. Now, with that in mind, we're going to spend, probably a couple minutes, but not very long, spend a little bit of time looking at the current portfolio of products. The only reason I happen to do that is because some of those things will be on the exams. Okay? If you're going for your ACE, not so much, because that's more of operational stuff. But if you're going for your CNSE, the full written test on there, then yes, you're going to need to know something about the different models that there are, and at least some of the comparisons. I'm going to throw things out here to you that are on data sheets, so don't get too hung up about it, but just kind of cover the major points on there. That's going to be really where we come into, to look at things. So really kind of for our first set, I want to go through what I would deem as the physical boxes, okay? And one of the interesting things up here, obviously there's a huge jump up in there. Your 7050 is going to be a blade device, okay? So that's going to be a much larger chassis and the ability of sticking different blades in there that gets you up to this 120 gig of firewall or 60 gig of what we call full threat analysis. So basically turning everything on, how much throughput you'll actually get in there. All of the rest of these down here are going to be chassis based. I have an asterisk on these three, so I'm kind of set them out to the side right here. And one kind of important thing about this is that they are end of life. However, they may still show up on the exam. So again, they're older devices, they've been replaced by the 5000 series, but you really kind of have to be aware of them anyhow in terms of what we get. Not really going to go through the details on how many interfaces each of them have. Do be aware that there is support for 10 gig. Really in my 4060 I had an old XFP, in my 5050 and 5060 I have SFP+. Most things these days for my gigabit are going to be in the SFP category, so that I can really put copper or fiber in things. When I get down to my lower end, though, specifically the 500 and 200, I'm going to be fixed copper ports only. So really have no option whatsoever for fiber in there. But, big thing as we start kind of go looking at the chart on things is notice that the firewall throughput and the full threat, okay, basically it's half is what we typically end up doing here. But the other difference comes in how many sessions, and in parentheses is how many sessions per second that the firewall is able to do. And we can see kind of a big jump between, the 4000 series at 60K per second and the 5000 series at 120K per second. Really, the 720, by the way, is just because I've got multiple blades. So, yeah, it's kind of like having multiple firewalls in a single chassis. Marketing math. So, again, we're kind of looking at these things in here, and this is going to be the part where I start to pick and choose which of the firewalls is going to make sense for where to deploy it in my network. The part about zones, virtual routers, and VSIS, or virtual systems, we'll get into in later nuggets, so don't be, hugely concerned about it right now. But notice that there is going to be a difference, again, in what each of the models happens to support, in where we're bringing things in and how much memory it's going to have, what the capabilities are CPU-wise, and all the other fun stuff that goes with it. But it's kind of a balancing act. Now, right here, my fun little guy at the bottom, I know, the lowest one on the totem pole, well, this is what you and I are going to be working on right now, because it's what I have in my network. We will also be playing around with some of the virtual machine versions. Okay? So, speaking of which, just to kind of bring that up here, we can go through and take a look at these as well, pretty much exactly the same way. A VM makes it kind of interesting because of the fact that, technically the processing is going to be the same for all of them. Okay, so when I look at my capabilities right here, either for full feature throughput or I'm sorry, full thread analysis throughput or just regular firewall throughput, it's capable of 1 gig or 600 meg. But my sessions, the number of sessions total, the number of sessions per second, is going to vary based on which I happen to be licensed for. Now, technically, that also varies depending on which hypervisor you're putting it on, which type of base system you're putting it on, and really other things along those lines. But your license will determine how you can grow. Each of them is capable of only a single virtual system, but 3 virtual routers in various zones that we have based on what my licensing happens to be. So I can grow things even though I can put multiples of these in a single physical box. So that's where I kind of overcome a lot of this idea. So, even if I had, say, 10 of the 100 series VM versions in a single physical chassis, technically my throughput would be 10 gig at that point. Technically my full thread throughput or full thread analysis would be 6 gig at that point. Number of sessions, obviously 10 times that, so 500K. So you kind of get into these things in here where we can play with it based on how many I'm putting where. But it gives me a whole bunch of different deployment options as I start to virtualize things a whole lot more. Interestingly enough, the VM side of things is really going to be key in people's data center deployments. And again, I suppose this is not a course about network design, so we won't get into all the different places that you can put them and what they're going to do and blah, blah, blah. That's really a whole different concept, and we may actually get into that for some real-world deployment options. But right now, cover the basics because that's the part that you're going to be tested on, and that's the part that's good to be familiar with for your entry into the world of Palo Alto networks. Again, kind of looking at where we're at from a lab setup is we're going to have a single device. We'll add second one in there once we get into the high availability portion, but basically protecting from the internet to multiple zones. Whether I separate out my DMZ servers or one group of users versus the second group of users versus my data center servers, I'll have different rules or different things that I look at, not just for traffic coming in here and splitting out, but possibly for traffic going from the users to the data center, or from these users over here to the DMZ, or wherever they're going, or outbound traffic. Whatever my rules happen to be, that's where I'll start to build everything as we go through this course here, so we can at least get a flavor for how I do this or how things will be set up in the real world. But that's about as far as I want to get as far as the device portfolio itself. Other considerations like how many power supplies and things like that, that's a data sheet thing. I didn't see anything on the exam that would really make me key in on that, or from a normal engineering standpoint make me think that I have to memorize that kind of information. So kind of take things as you will, but notice some interesting stuff from the hardware perspective, but that's the device portfolio overview and a place to get us started. Okay, so kind of, now that we're done with the boring part about looking at speeds and feeds and all that jazz in there, this is where we get into really the sexy side of what makes Palo Alto cool. And there's a number of different things that go along with it, but honestly it has to do with processing. There's a number of things, when we see next generation, there's a lot of different things that come into it, because technically anything new is next generation, otherwise it'd be boring old stuff and nobody's going to mark it that way. So forget about the term next generation firewall for right now, because it's being way overused in there. But what we want to look at is a method of processing and the steps that we're going to go through. This, as far as a flow chart, is very, very important, especially as you go through your CNSE exam, because you will get tested as far as like order of operations when things occur versus one another. So it is important to kind of get through this. You will see it, or you'll probably see a prettier version actually if you download some of the free materials on Palo Alto's website. This is me and my Visio skills. But beyond that, it is nice and colorful and it is lined up. So let's kind of work with that one in there. But what we're going to see as far as what it does is how the processing is done. And we have a couple different terms that we'll look at along the way, and one of them is SP3, okay, which is actually SPPP, which stands for Single Pass Parallel Processing. Okay, so that's one of those fun little acronyms to kind of come up with along the way. And what it really says to us is all of these things right here, so my in-depth checks, so the things that are going to be very important and very CPU intensive along the way, all occur at the same time. Alright, so this is my SP3 area, and this is done via multiple CPUs. So parallel processing, of course, means that everything is happening at the same time. So that is going to be key as far as the latency on the firewall, and as far as the speed, the total throughput, my capabilities as we go through here. So kind of keep that part in mind. But, you know, I mean, security flow is security flow. Okay, so the SP3 is part of the marketing stance of stuff, you know, that you go through. Everything for antivirus, spyware, data filtering, various vulnerability protections, all those things, all going to be handled simultaneously in there. It also minimizes the amount of buffer space that we need. So again, going back to the latency point of view being significantly better in how we look at it. But first things first, okay, so a packet is going to come in here. And, you know, we have initial checks that we kind of have to do to begin with, basically to find out whether it's a good packet or not. So there are some checks that actually happen right over here. Obviously not just at the layer 2 level, because we'll have our CRC information stuff come in. We'll do the same at layer 3 and layer 4, and we have some basic checklists as far as anomalies go. Okay? So there will be some things that go on that we may be able to discard packets right away. If I have a fragment policy, that may be another thing. If I get a packet fragment come in and don't want them, well, kill it. Why bother looking up anything when, well, some things you can't anyway, but why bother spending the time going through extra processing when you know it's going to die? So everything we can do to try to rule things out early on is better. Once we determine that it's a good packet, though, by the way, then we start doing some lookups on it. Okay, so we start looking at the source zone and address. That's going to lead us into the policy, really, okay, as far as what's going to be going on. But the forwarding lookup, once I'm inside that particular source zone, what do they have access to? What do they not have access to? What am I able to do in there? Okay, I don't know what actually just happened there. So anyway, as we get through here for our forwarding lookup, PBF, by the way, is policy-based forwarding in case the policy actually tells us where to go. But either way, we're going to figure out what the actual path happens to be. And during that, we'll decide whether it's going to be any NAT or anything else along those lines. But that whole thing is going to be our fast path check. Okay, so basically determine whether a session already exists or not, whether I already know what I'm doing with it or not, or whether I have to go through the whole slow path processing. Or slow path. Okay? But all of that's going to take place and decide what's going to happen. If I am going slow path and nothing has happened, then I'll go through the actual policy, the pre-policy part, check my ports, and actually create the session so that I have the starting point for everything. If I fast path, all of these decisions have already been made, so I can go ahead and quickly kick it in and decide what it is I'm doing, because I already have the app ID based on the session and everything. But I'll do any, you know, decryption or any other further checks, content ID and stuff like that I have going on. Okay, so like we said, one of those things that makes it different from the Palo Alto side of the world is the next generation idea of using user information. So all the user ID stuff, using application information, so we call it app ID, and of course other things like the content specifics itself. So content ID helps me look for things, like social security numbers, credit card numbers, fun things like that along the way that we don't want to have. This kind of focus. Now, nowadays we kind of look at it and say, all right, but everybody says that. This is true, no doubt about it. Somebody, however, had to be the first to market to go ahead and do this. And that's where really Palo Alto got its niche. Fun things historically, of course, is that, remember, the guys who created Palo Alto actually came from Juniper Networks / NetScreen and kind of went off and formed their own company. So, but it's all competitive. These days, Juniper Networks has application-based stuff. Cisco Systems has application-based stuff in the ASA. So, we're all coming around to this, which is part of why I say next gen is way overused at this point. But this is where, like I said, we get into our processing side and see how things are going to be a little bit different. But entire flow chart about how we're going through here and either creating our session or kicking it into then my parallel processing portion, and of course post-processing to send it all out, back to the interface or decide where it's going to go. That's the important thing about how we're pulling stuff together. So very basic things that we went through on here, like we said, we had to do with the device portfolio, kind of get an idea both for the for the physical and virtual devices that we have. One thing that I did forget to kind of put in there is our management. So we have something called Panorama, which can come again in a virtual device or in a physical device, just a single box for each, so nothing too interesting. But that's going to be my enterprise manager. We will have specific nuggets that go over that and the configuration of it as well, so just kind of wanted to throw that in. But, physical and virtual of my devices to get some familiarity with it. And then my architecture, my key takeaway on this was the SP3. So what kinds of things go into it to make this a next generation firewall? And yes, I said that was a very overused term, but we had things like the user ID and my app ID, and what was that other one? Oh yeah, the content. So basically going in to be able to be very specific in terms of where we're at user. So all the catchy things. So this is the type of stuff, though, by the way, for my packet flow that I would say is the most important thing to get through. So come back to it often, come back to it frequently, screen capture, print it out, do whatever you need to do, but be familiar with that order of operations, because when it comes to the exam, if you choose to take the CNSE in particular, then you will be tested on that part. But that gives our basic familiarity for it, and I know we just had to cover the boring stuff first, but now it's time to actually get into some of the concepts of the device next and how to use the actual stuff. You ready to play? I know I am. I hope this has been informative for you, and I'd like to thank you for viewing.